Welcome back to Electrical Engineering 1. Once again, this is your lecturer, John, and my student, Matthew Tan.
Hey everyone.
This time, I'll introduce you to the central concept in electrical circuits, which is Ohm's law. Resistors will also be discussed in detail, as well as voltage and current laws. One of the basic property of materials is called resistance. Materials tend to resist the flow of electricity through them. The resistance of a material is a function of its length, cross-sectional area, and the material's resistivity. It means that the greater the length of a material, the higher will be the resistivity. And the smaller the cross-sectional area, the greater will be the resistance. This table shows the resistivity of common materials. This table shows that silver, copper, aluminum, and gold are being used as wires. Ordinary consumers are using copper, but microelectronics manufacturers are using gold and silver in their wires. So those ICs, your handphones, all electronic circuits have gold wires in them. Any questions?
So I'm sure most students would want to know this. Can we actually sell those gold wires to gain profits?
Yes, of course, as long as you can remove the wires inside these chips. But you see, these gold wires are smaller than the strand of your hair. So to be able to come up with even 1 gram of gold, which is 24 carats gold, you need thousands of these chips. So you see, manufacturers are using gold and silver because of their good conductance. But ordinary consumers cannot afford gold and silvers in their wires, so they use copper. One of the basic laws in electrical engineering is called Ohm's law. What is Ohm's law? Assuming we have a resistor, the voltage across that resistor is directly proportional to the current flowing through it, which means that if we have a 1 ohm resistor and we have a 1 ampere current flowing through it, then it means that there is a 1 volt voltage across that resistor. This means that the higher the resistance, the less current will flow through a given circuit. Take note that Ohm's law requires conforming to the passive sign convention, which means that current will enter through the positive side of a resistance. Normally, you hear about short and open circuits. Basically, short circuit means that current flow through the circuit. In practice, this is simply a connecting wire. A connection with an infinite resistance, which means that no matter the voltage, no current flows through it, then it is called an open circuit. But Ohm's law is not sufficient for circuit analysis. Kirchhoff's law completes the needed tool. So in our circuit analysis, we will be dealing with 2 laws. The Kirchhoff's voltage law, which is also called KVL, and Kirchhoff's current law, which is called KCL. Now, a knowledge of Ohm's law and Kirchhoff's law will enable you to analyze almost every circuits, electrical or electronic circuits. Any questions?
Okay, so when it comes to the laws, will there be any more formulas to remember in electronics engineering besides Kirchhoff and Ohm's law?
Yes, in electronics engineering, there will be other formulas related to the device. But you see, all these formulas are all based on Kirchhoff's laws and Ohm's law. So a knowledge of Ohm's law and Kirchhoff's law plus the knowledge on the operation of the device will enable you to analyze any electronic circuits without necessarily remembering the exact formulas. KCL, or Kirchhoff's current law, is based on conservation of charges. It states that the algebraic sum of currents entering a node or a closed boundary is zero. In other words, we can say that the summation of current entering a node is equal to the current leaving that node. KVL, or Kirchhoff's voltage law, is based on conservation of energy. It simply means that the algebraic sum of voltages around a closed loop is zero. So, you see, in KCL, it is the summation of current, which is zero. In KVL, it is the summation of voltage, that is equal to zero. In electrical engineering, sometimes we cannot have the resistance that we need. That is why sometimes we use a combination of these resistors. One type of combination or connection is called series connection. Thus, we have series resistors. Two resistors are considered in series if the same current passes through them. Take a look at this figure and you will see how the two resistors are connected in series. If you are going to apply Ohm's law to both resistors, then we can say that the voltage across resistor 1 is equal to the current through it, which we shall call I, multiplied by the resistance of that resistor, which we call R1. Similarly, for resistor R2, we can say that V2 is equal to the current through it, I, multiplied by its resistance R2. If we are going to apply KVL to this circuit, then we can say that the magnitude of the voltage source V is equal to the sum of the voltages across resistors R1 and R2. Thus, we can say that V is equal to V1 plus V2. Now, since V is equal to V1 plus V2, and knowing that V is equal to IR, and the currents passing through the two resistors are equal, we can say that R1 plus R2 is the total resistance in that circuit. Thus, we can say that the total resistance in a series circuit is the summation of the individual resistances in series. In a series circuit, the voltage drop across any resistor can easily be known through voltage division. Thus, referring to the previous figure, we can say that the voltage across the resistor R1 is equal to R1 multiplied by the voltage source V divided by R1 plus R2. Similarly, the voltage across the resistor R2, which is V2, is equal to R2 multiplied by the voltage source V divided by R1 plus R2. This principle is called voltage division principle. Another type of connection is called parallel connection. In this slide, you will see how parallel resistors are connected. When the resistors are connected in parallel, the voltage drop across the two resistors are the same. So you see the difference between series and parallel. In series, the currents are the same across two resistors. In parallel, it will be the voltage that will be the same. Now, since the voltage are the same, then we can say that the total current delivered by the source is equal to the sum of currents passing through each resistor. In parallel circuits, the equivalent resistance can be written as R1 multiplied by R2 divided by R1 plus R2. Take note that this formula is only applicable if only two resistors are connected in parallel. You can use this formula if three or more resistors are connected in parallel, as long as you take two resistors at a time. In series circuits, we have the voltage division principle. In parallel, we have the current division principle, which means that referring back to the previous circuit, the current through the resistor R1 can be written as I1 is equal to I multiplied by R2 divided by R1 plus R2. I is the total current delivered by the source. Similarly, we can say that I2 is equal to I multiplied by R1 divided by R1 plus R2. So we have come to the end of Chapter 2 of A101CEC, Electrical Engineering 1. If you have any questions, you can always post them in Google Classroom. Thank you and have a great day. Remember, work hard, work smart, and work your way to your dreams.